So, in the previous lecture, we talked about two main factors that affect distribution network design: what customer values plus the cost. Now we want to actually take a look at some design options and evaluate them based on their effect on customer value as well as the cost. So in order to actually create any of these designs, we have to answer two questions. First of all, will the product be delivered to the customer location, or customers are supposed to pick it up? And then the second question is, will the product flow through an intermediate location, maybe a distribution center or a retail store, before reaching the customer? So answering basically the answers to each of these questions will affect the design that we select for the business. So let's take a look at each of these design options. First of all, there is a design of a distribution network that is called manufacturer storage with direct shipping. It is also known as drop shipping. I'm sure that you heard about drop shipping before. So what happens in drop shipping is that we do have manufacturers producing different kind of products. We have retail stores, obviously, and also customers. So customers place an order, and this information goes to the retail stores. And then retail stores communicate the customer request with the manufacturers, and then manufacturer is going to directly send customers the products. So retail stores are here just a communicator. So a retail store here is just a communicator of customer order. I'm sure that you can think and find examples in the real world for this design, but an example can be Nordstrom. So have you ever placed an online order from Nordstrom? If you did, you might realize that there are different actually packages coming to your door. So if you, for example, place an order with multiple products in it, sometimes it happens that each product is being shipped separately. And the reason is that, again, there are different manufacturers, different products, or different basically uh, providers, and each one will send you a product or a couple of products at a time. So this is how actually businesses try to consolidate their inventory. Instead of having everything in many different retail stores, they just keep most of the inventory in centralized locations and reduce the cost of facilities in this way and cost of inventory in this way. So here's a table that shows the performance of this distribution network design. First four rows are the cost factors: inventory, transportation, facility, and information cost. And then the rest is what customer values. So we want to figure out what are the weaknesses and strengths of each of these design options. So in terms of inventory, maybe there is a strength if we are interested in low cost of inventory. Since we don't have distribution centers that much or retail stores that keeping all the inventory, we have just centralized locations for the inventory, so we have low cost of inventory. In terms of transportation, the cost of transportation might be high, and the reason is that from manufacturers, which are far away from the customers, there will be small amount of shipments. And each time a customer places an order, there will be a shipment. So there are so many small shipments for long distance. Facility cost might be low because we are aggregating all these inventories in centralized facilities, so we don't need many distribution centers. In terms of information, we need definitely significant investment in information infrastructure because there are so many um, uh, things happening in between, right? So customers place the order to retailers, and retail stores are communicating that information to manufacturer to several manufacturers, and then several manufacturers are sending packages to this same customer. So there should be a good, very good, actually, a system, information system that helps everyone in this supply chain to track what's happening, what's going on, specifically the customers, where their packages are, when they will be delivered, and so on. And then in terms of customer value, if a customer values response time, they might not go with this business. Usually, because manufacturer centers are really far away from customers, it takes long time for the products to be delivered. But since the inventory is centralized, so they have usually large centers with a lot of inventory, so they can provide variety, they can provide availability. But customer experience is different. So if customers are interested more in walking to the store and seeing things and then purchasing, it's not really good. But if they prefer home deliveries, this is a good option. Time to market is usually fast because since manufacturers are responsible to deliver the demand, they need to be aware of trends out there. So if there are any trends, any new developments with um, similar products by the competitors, manufacturers can easily get that demand, get that trend based on the sales data, and then adjust the product accordingly. Maybe manufacture new trendy products or just customize the existing product. So they have this direct information and they can implement in their product. And then order visibility might be difficult if there is not a good IT system. Returning the products might be expensive and difficult for the customers because they have to ship it back to the manufacturer. It's going to take time to be processed. So the next design is in-transit merge network. So this is an interesting, actually, design. In this network, we have the factories, manufacturing centers, assembly sites. We have actually retail stores as well. We have in-transit merge by carrier as well. I'm gonna explain. And then customers. So let's say that customers place an order. That information goes to retail stores, and then retail stores pass that information to the factories or the manufacturing centers, assembly sites. And they want to fulfill the customer order. But what happens is that usually they work with a third party, um, such as UPS, FedEx, and UPS, FedEx do have hubs in certain locations. So if there are different manufacturers sending multiple packages to the same customer, all the packages goes into that hub in transit location, and then they are being merged into one single package and then being delivered to the customer. This way, actually, the system can reduce the transportation cost. Instead of sending three different packages separately to the same customer, they are just sending one package, combining all that, merging all that. So, again, carriers such as UPS, FedEx, they do this for many different businesses. So, in this table, again, we can talk about the strengths and weaknesses, cost and customer value. So inventory is very similar to drop shipping. Transportation is a little bit lower because now we are consolidating many packages into one. And again, example is, let's say that you're purchasing Apple products. You are purchasing a PC and then some accessories. Instead of getting every single thing, every single one of them in separate package, usually you get the entire thing in one single package. And the reason is that they actually merge all these pieces together and then ship it to your door. And then facility cost is a little bit higher because now we need actually a center in transit location that can do these kind of operations. Information, again, we need a very good information system so that we can track what's going on in the entire supply chain. In terms of customer values, response time is very similar because the steel manufacturers are the ones that are sending things. They're far away from customers. Variability, availability is the same. Again, they are high because we have centralized locations. Customer experience can be better. Instead of receiving multiple packages at different times, now they receive only one package with everything in them. Time to market, order visibility, and returnability are the same as drop shipping. The third design option is distributor storage with carrier delivery. So this is also a design that we see in many examples in real world. I want you to think about it. So in this case, we have all the manufacturers, the providers, we have the warehouse storages. It can be by the distributor or they can be retail stores. And then we have our customers. So what happens is that customers go to the retail store, purchase the stuff. All the factories, manufacturing centers are sending inventory to these warehouses, to the retail store. So it's easy for the customers to just walk in and grab what they want. If they place online order, again, the orders go to the retail stores, being shipped to the customers directly from there. Obviously, this is um, used by Amazon specifically, right? It's in early stages where they had these huge warehouses with a lot of inventory in them, and they were fulfilling customer demand from their huge warehouses. So in terms of inventory cost, there will be a larger inventory cost because now instead of having one manufacturer with all inventory in it, now we have different distributions and retailers. Again, in this picture, it shows one, but in real world, we might have many, right? Many retailers, many distributors. So there are many of these facilities that needs inventory, right? And also safety inventory. The transportation cost can be lower because we can consolidate the transporting the inventory from manufacturers into the warehouses in full truckload, and then from retailers to customers, shorter distance, so lower cost of outbound transportation. Facilities will be higher. The reason is that we need to build warehouses, retail stores, distribution centers. Information infrastructure will be a little bit better because now um, customer orders not going to the manufacturers, so they don't really need to be in loop of the demand. In terms of customer values, response time will be faster because now customer can just walk into the retail store or their orders will be fulfilled from the retail store. Variety and availability will be lower, and the reason is that now we have smaller centers compared to manufacturing centers with the inventory, so there are limited inventory available in these locations. Customer experience will be better because they don't have to wait a long time for the manufacturers to send stuff to them. It's going to be faster. Time to market will be higher, meaning that since the manufacturers are not in loop of the demand and market trend, they're not in reach of the customers directly, so they don't get the information about market fast enough to deliver new developments fast to the market. So it takes time for them to realize the trends and stuff that are happening in the market. And therefore, time to market to develop new things will be longer. Order visibility will be a little bit easier because, again, customers can walk into the store and have information about when their um, package will be delivered. Returning purchases will be easy again because these retail store distribution centers are close to the customer, so it will be easy for the customers to return. The next design is distributor storage with last mile delivery. So I'm sure that you hear about last mile delivery so often these days. There are so many new companies are actually doing last mile delivery. For example, Instacart or Amazon Fresh. So these are last mile deliveries. You can place an order on Amazon Fresh and they deliver the same day. So you can purchase different kind of groceries and stuff. The same with Instacart, right? So the same day delivery because it's a last mile delivery, meaning that it's a very short distance, close to the customer, and the goal is to fulfill customer demand. If you remember, we talked about failed business, Webvan, the same thing. So they try to actually do grocery delivery the same day. Long ago, when there wasn't any particular demand for it, so they failed. But these days, people are very busy, obviously, with traffic and gas prices. It seems that people are interested in trying these kind of services. So it's interesting that Google had something like that before as well, Google Express, but they retired it in 2019. So they don't deliver products and groceries to customers anymore. So in this design, we have again manufacturers, factories, and we have distributors, retail warehouses, and also customers. And instead of connecting all the distributors and retailers to all the customers, now we just segment our customers and then allocate customers to specific retail stores, specific distribution centers. So we try to get actually the closest retail store distribution center to the customers so that we can deliver to them fast. Promising last mile delivery should be fast and convenient for the customers. So also I want you to notice that when a customer places an order, maybe when multiple customers are placing an order, the retail store will grab all of them, and actually wait a little bit to get everything. And then we'll have a van or a truck, a small truck, so that it starts delivering to all of the customers and getting back to the retail stores. So the delivery is not just one by one to the customers, it's delivering to a sequence of customers at once. This helps to reduce the transportation cost. So in terms of inventory, things are higher. We need more warehouses so that we can be more local, close to the customers. Transportation can be really high again because we are doing last mile delivery. These are small shipments. But again, trying to ship multiple customers at a time so that managing the transportation cost to some extent. Facility costs will be higher. We need retailers, retail stores, distribution centers. Information will be similar to the past. Still, we need to track. So we need actually information to be shared with everyone in the supply chain. In terms of customer values, response time will be very fast, promising the same day delivery is available now with the system. Product variety will be less because now we have multiple distribution centers and obviously smaller than factories, and we can have limited amount of inventory in them and stock inventory in them. So availability as well as variety will be less compared to the first two options where we were shipping from the manufacturing centers. Customer experience will be very good actually. So you can just place an order and get it delivered in 2 hours. Time to market will be slower. Again, manufacturers are not in direct contact with customers and the market trend. So it's going to take time for them to realize what's going on and make changes. Order visibility will be easy again since it is locally fulfilled. So it's very easy for the customers usually through an app to check when the product will be delivered. And then returning will be easy as well. Sometimes the vans that are delivering also accept returns. So we can just give it back or returning to the local retail store will be easy as well. And then the fifth design is manufacturer or distributor storage with customer pickup. So this is an interesting design as well. I'm sure that you saw this before. For example, Amazon enables you to purchase online and then go and actually have a locker. They place it in a locker and then you can get it from the locker. So there are some manufacturers, factories. We do have retail stores. We do have cross docks. So cross docks are actually usually in cross docks we do not keep any inventory. Cross docks are not warehouses. Cross docks are only used in order to just if we are getting full truckloads, we can actually separate them into smaller loads and ship them to different destinations. Let's say that there are full truckloads coming from a factory to a cross dock, then it will be break down into two shipments to two different pickup sites. Okay, so cross docks are not keeping inventory, they're just helping to reduce the transportation cost because now we can have full truckload to some extent and then break it down into smaller pieces, getting closer to the delivery point. So the pickup sites are available in many different locations, and customers can actually walk or drive to these locations and pick up their order. So customers gonna place an order, information gonna go to retail stores, and then they will share the information with factories. Factories will send full truckloads to cross docks. In cross docks, there will be operation to break them down into smaller pieces and send customer orders to pickup points. Customers gonna walk or drive to those pickup sites and grab their products. So there are different examples. Walmart enables this. Actually, you buy online pickup in the store, right? They have pickup site, and that was Amazon's struggle. Walmart could easily actually add this feature for customer experience, but Amazon didn't have it before. So they tried with these like pickup boxes and those kind of things, lockers and stuff. So in terms of inventory cost, it can match any of options. It depends on the inventory that is being kept. But again, the thing is that we do have retail stores, many retail stores, but not necessarily keeping any inventory in cross stocks. In terms of transportation, it can be lower, specifically than package carriers. And the reason is that now the transportation from cross-docks, cross-docks are helping actually to reduce transportation costs because we do have full truckloads and then breaking down them closer to customers. In terms of facilities, it will be high again, if those pickup points are so many, so we are building actually new pickup points. Information systems still will be a significant investment because there's so many things happening, specifically the demand information goes to the manufacturers. So we need a good system, information system to do that information sharing. And then response time will be similar to pass. Again, those are the manufacturers who are fulfilling the customer demand. So it's going to take some time to get the products. Product variability and availability will be good, actually, similar to our first two options, because again, things are being shipped from manufacturers. Time to market will be good again since manufacturers are in direct contact of customer demand. Order visibility will be difficult if you don't have good IT system. Returnability will be a little bit easier since we still have those retail stores. So customers actually can go and return in retail stores. Sometimes it's possible to keep it back, give it back into a locker. So if that's the case, also it will be convenient in terms of returning the products. And the last design is retail storage with customer pickup. So this is a very classic example, right? So there's some manufacturing centers, there's a distribution center, and then retail stores. Customers walk into the store or they place an order online, and then retail store fulfills the customer demand. You can see this in Home Depot, for example. So in terms of inventory, this will have high inventory cost. The reason is that we have so many retail stores close to the customers. For example, Walmart, Target, um, Home Depot, they're close to customers, so customers just can walk into these huge retail stores. So there's so many of them. Inventory cost is high, facility cost is high. In terms of transportation cost, to some extent, it's not bad because we can do still full truckloads to the DCs and then break them down from DCs to these retail stores. Information system, a little bit better because all demand requests go to the retail store rather than manufacturing centers. Response time will be actually immediate, right? So customers can walk into the store, purchase the stuff, or actually they place it online, go and pick it up in a store, or basically same day pickup, right? So, for example, Target acquired a startup company a few years ago just because they had developed a system of um, order online, pick up in a store. So they acquired actually their algorithm and implemented it in their system. So they know exactly what kind of demand is coming in, what kind of inventory they have in the local store, which store should be assigned to that demand, and how long will it take to fulfill that. So all these calculations are being developed by that kind of algorithm. So product variety will be lower instead of having access to the manufacturing centers. Now there are retail stores that are actually providing products. So product variety availability will be lower. Customer experience will be positive or negative depending on customers. So if a customer prefers to go to the store, see things, and purchase them, so their experience will be really good. If they prefer to stay home and just get things delivered, so it's not the case. Uh, Time to market will be high because manufacturers are not in direct contact with the market. Order visibility will be really good because you can just walk in, pick up in a store, and returning will be easy. Again, customers can just walk into the store and return if they don't want a product. And here's a quick table that summarizes what we covered, also compares these 6 designs, considering the main costs as well as main values of customers. So I would encourage you to take a look at this table, compare things, and then it will be easy to figure out which design to go with in case a business wants to be cost efficient or wants to be more responsive. And then I have some questions for you to check what you learned so far in this lecture. Please pause the video, look at these questions, think about the answers, and then you can find the answers in the next slide. The first question is, match each company to its primary distribution design. Nordstrom, Amazon Prime, Walmart, buy online, pick up in a store, Dell PC orders in the past, maybe in around 2000. Justify why you selected any of the designs based on maybe the tables that we talked about. Second question, a furniture retailer sells 500 SKUs, 90% of which have very low weekly demand. So this is a key. If the demand is low, then what distribution design will you recommend and why? And what would be the risk of going with that? And then question 3, last mile delivery always provides a better customer experience than retail store pickup. Is this true or false? So remember that what customers value might be different. What customers, so customer experience might be different, right? So consider that when answering this question. And then last question, a pharmaceutical company wants to distribute specialty medications nationally. Response time is critical. It should be next day. But variety is limited, only 50 SKUs. Cost is a concern. I want you to rank top 2 distribution designs for the scenario and also explain your reasoning. So think about these questions and find the answers in the next slide.